In this problem, we want to prepare the tri-substituted benzene from benzene. And we have this ethyl group and the two bromines, and they're all meta to one another. And a common strategy that sometimes people will think might work is to put this ethyl on as an acyl group. But let me show you the problem with that. If you have this acyl group and you try to do a bromination, that will work just fine to add a bromine meta. The issue, though, becomes adding that second bromine in, because this bromine is now our primary directing group, and it's going to direct the next bromine ortho and para to itself. So we can't correctly install the second bromine. So that means we're going to have to use a different strategy. And it may not be readily apparent, but remember that we can put on an NH2, convert it to a diazonium ion, and we can eventually remove it such that it's just a hydrogen. So with that in mind, here's the strategy. We're going to start with benzene, and first put an NH2 group right here. All right, that NH2, we're going to use that as kind of our main director and take advantage of it, but eventually remove it. So we're going to put that NH2 on. We're going to convert that to a bulky group. That will allow us to install the ethyl. Then what we're going to do is remove. From there, we can brominate. So eventually we'll get to the stage where we have the ethyl, the NH2, the two bromines, and then ultimately, by the end, we're going to get rid of this. Remove it completely. So that's the strategy for this problem. All right, so we're going to start by getting that NH2 on the ring. So our two-step sequence to do that is the nitration followed by the reduction. There's our NH2. Now let's turn that into a bulky group. All right, so with that bulky group, the positions ortho to it are blocked, but we can install something para. And that thing that we want para is the ethyl group. So I'm going to use ethyl chloride and aluminum trichloride. The Friedel-Crafts works just fine with the amide, so there's no problem there. Now we have our ethyl group. Next, we need the NH2 in order to dibrominate at those ortho positions to it. So let's get rid of the bulky group. And we can do that with acid and water. All right, now that we have NH2, it's an ortho-para director. Its para position is used up with the ethyl, but its ortho sites are open. So now if we brominate, and we don't need a catalyst with that strong activating group, we'll dibrominate. All right, well now we have everything we want, but we also have something we don't want, the amine on the ring. But we can get rid of that. So let's convert it to a diazonium ion. And then we can convert that to a hydrogen with H3PO2. And we're left with our final product.